Hey, what's up everybody? Welcome to TGIK live from the Heptio studios. I am your host, Kris Nova, and we're going to be talking about Kops or KOps or Kubernetes operations, I think was the original name, a lot today. And as we like to start off every episode, we're going to say hello to some of our friends online. So let's pull up our chat here and see who's all joining us today. Happy Friday, everyone. It's good to see you. All right, so Lamati, first in line, as usual. Good to see you, Lamati. Olav, hello. It says howdy there and happiness right back at you folks. Evening all from Rory. Oh my gosh, I love that name. That's one of my favorite names. Yay, Friday. Happy Friday, TGIK fam. Good to see you, Aaron. Rudy, happy Friday. Greetings from Hamburg, Germany. Suresh, one of our other frequent attenders. Hello, Michael. Hello from Paris. Hey, Felipe. It's good to see everybody. So we like to start off our episodes saying hello, and then we usually go through and we jump in and look at kind of what happened in Kubernetes this week. And over the past couple of episodes, I've made it a point to kind of talk a little bit about an interesting part of the Go programming language and spend, a minute or two talking about, some sort of like feature or interesting paradigm or some sort of concept or an article that we find on Reddit. So we have a little bit of Golang 101 here at the beginning of the episode as well. And it looks like other folks are catching up with the buffer here. So let's see who else we have. I think we stopped at Felipe from Paris. So we have Noah from Las Vegas, Olaf from Havana. It's good to see you, Carlos. Nicholas, hi from Santa Clara. Philip, hi from Germany. Brian Lyles says Jello or Soft J, hello. Hi from London, good to see you, Nadir. Nadim, hello. Doug, hey Chris. And Gift, hi. My favorite one is just HI, that's the best. Okay, so let's jump in and let's look at the episode for the week. How do I do this? Let's go to screen and face, poof. Okay, rad. So for those of you who don't know, over the past 30 days or so, I've been recovering from a hand injury. I had to get helicoptered off of Mount Rainier. So this week, when we're doing Kops, I figured it would be appropriate to find, I figured it'd be appropriate to have a helicopter, and it was one of the images I found when I searched Unsplash for, I think I typed in officer this week. But anyway, that's the reason that we have the helicopter with police on the back is for Kops in my helicopter accident. So anyway, George has put together this really lovely framework for us, and down here at the bottom we have reference links, and throughout the show we have show notes. And I think I was talking to George a little bit this week at OSCON. I just got back from Portland. We were down there all week and just drove up last night with Francesc about this new tool he found. I think him and Joe used it a couple weeks ago, and it allows for folks to like live contribute to our show notes. So here in the future, I think we're going to try to like use that a little bit more, and hopefully we can find an interactive way for folks to take notes and contribute as we go through the episode. And of course, as always, we love when people comment in the chat and give us pointers or ask questions, and we can actually take some of those questions and some of those pointers and feed them right back into the episode here. So let's go through the links that I put together for us this week. And this week, again, like I feel like I say this more and more, but it's kind of been a quieter week in Kubernetes as far as like open source announcements or big tooling or big exciting things. I found a couple of cool things that I noticed while I was at OSCON, but I was also kind of like wrapped up in conference mode all week. So if anybody has anything else they want to share, now would be a good time to drop it into the chat. But the first one is the actual repo for the tool we're going to be looking at today. So to be completely honest, I think the last time I looked at the Kubernetes Kops repo, we had less than 1,000 stars. Actually, I think we had less than 2,000 stars. And I was like the second largest contributor, and it was like a year and a half ago. So I kind of had like no idea what I was getting myself into. I used to be a big contributor. I'm still a registered maintainer of the project. I haven't actually looked at Kops or touched Kops in quite some time. So I kind of look at myself as like a retired Kops contributor, Kops maintainer. And I just kind of jumped into the repo and I scrolled down and like, we got a new logo, so that was really cool. I didn't realize that we had a new logo. And I remember I spent a lot of time making this README nice and pretty in the long ago, and I came through, and this is my original ASCII cinema that I recorded. And what's really cool is if you actually look, it says, recorded by Kris Nova 2 years ago, and it's still here. So this is pretty cool. I made this like a long time ago when I still lived in Colorado, and it's still like online, and hopefully it's still relevant. So we're going to find out today. We're going to be going through and doing all of this from the ground up. So anyway, let's go back. Well, we're going to talk a lot more about Kops later, so let's go talk about some of this other stuff first. Let's see. Looks like we have some questions. Or actually, we have some hellos and some questions. So let's read those really quick. Okay, so last one was hi. We have Ashish says, hello from Pike Place Market. Hello. Happy Pike Place Market. That's cool. I want to go work from Pike Place. That place is awesome. We have hello from Santiago, Chile. Hello, Iru. Pav, hi. Pablo, hello from Chile. Esta Rocks. Good to see you, Pablo. Thanks for clarifying. I'm still working on my foreign language skills, so you guys are going to have to bear with me. Carlicia, hi. It's good to see you, Carlicia. Welcome to Heptio again. I know I've already told you like 100 times, but it's good to see you. Every time I see your face, I get happy. Jason, good to see you as well. I feel like I see you a lot on the cluster API calls, but it's good to see you here. Abdenor, hello from Tunisia? I think I said that right. And Lamati says, what were your top 3 things from OSCON? So honestly, my top 3 things from OSCON, this was the first conference I've been to probably in about 2 years, where I actually just went as an exhibitor. I didn't have a speaking slot. I didn't go to any of the sessions. I wasn't even allowed in any of the sessions. I just hung out at the booths the whole week and just did a handful of interviews. I did some podcasts. I hosted an event, and I taught a workshop for 2 days, along with some of our other folks in training, Ryan and John. So it was really low key for me. Like I kind of just got to like hang out and talk to people, and I don't really get to do that much anymore. So that's definitely my number 1 from OSCON, was my ability to just chill and, you know, have a good time and just be calm at a conference. I really don't get that much these days. Another exciting thing about OSCON was I got to do one of our trainings, and I learned about some really cool stuff that we do in trainings. And I think the third thing at OSCON was the Kubernetes trivia night that we put on Wednesday. So big shout out to folks at Google and CNCF and Red Hat who helped with that. That was really fun. We like basically did Kubernetes pub style trivia, and I got to host it. So I got to ask all kinds of like silly Kubernetes questions and try to stump people. So that was fun. So those are my big 3. Anyway, Felipe says, what would be the best tool for creating a production-ready operator today? Sample controller, queue builder, operator SDK, or other? Felipe, that is a great question. I'm going to actually take a note really quick, and we'll talk about that at the end of the episode. Actually I can just talk about it now. Why not? We've done a couple of TGIKs on the operator SDK and on queue builder. There's pros and cons to each of them. How they solve the problem is pretty much the same. It depends kind of what you're looking for. I think both queue builder and the operator SDK, they're the only 2 I've worked with. I know a lot of other folks like Meta Controller, but they all kind of solve the same problem of like getting rid of the boilerplate for you. In the cluster API working group, we've been entertaining using queue builder. It ships with a little more features, and it doesn't have any proprietary SDK on top of the Kubernetes libraries. You just get good old-fashioned Kubernetes libraries vendored into your controller. So that's the direction we were talking about going in open source. I did a live coding demonstration in Iceland with the operator SDK and a TGIK on it. It works great. It's really simple. You could probably write an operator in less than an hour if you just wanted to sit down and play with that. So they're all good. So maybe poke around and try a few and let us know what you think as well. And feel free to watch any of the TGIKs on them. Joe Thompson, greetings from sunny DC. And Leonardo, hi from Brazil. Good to see everyone. Okay, we've been staring at this helicopter for long enough. Let's go and look at what else we have here. So the other link I wanted to put in was this cluster API link. So this is like sort of my new project in Kubernetes. And you know, I really am curious, like if I come back 2 years later from this, if this I really want to put this on YouTube, because if it's true, I want to YouTube back and point to this clip. I'm wondering if this 117 GitHub stars here is going to turn into 4,000 or 6,000 stars in a couple years, and I can come back and be like, I remember when we did the TGIK 2 years ago. But anyway, this is a cool new project. I've got a lot of material out there. I wrote a book that talks about a lot of the concepts in this project, and we have a whole working group, and I could rant about this thing for forever. So we're going to get more into why this is relevant as we start looking at the Kops source code, but this is just here as a reference in case folks want to find out more or actually start looking at the code here as well. Oh man, there's a lot of questions today. I have a feeling this is going to be a super interactive episode, and I'm just going to be doing a little bit of Kops, but that's cool. So let's see what folks are saying. Ivan Fetch says, first time joining live, hello from the mountains in Sandpoint, Idaho, where I'm currently nomading. Ivan, you sound like a really cool dude. If you're nomading in the mountains, we should hang out. I love the Idaho mountains. They're some of my favorite ones. I also am really fond of the pass going into Wyoming, and of course the Tetons are some of my favorites as well. So cool. I'm glad you're hanging out in Idaho. Welcome to TGIK for the first time. We're glad you're joining us. Let's see. We have Aliciano. And again, I'm horrible with names, so please correct me if I use wrong names or wrong pronouns ever. And they say, I'm using Kops for several clusters, and I really like the design. What I'm not a super fan of is the lag behind the official Kubernetes releases. That's a really great point, and I'm going to start like a little notepad over here. Let's see if I can do this right now. Let's do dock camera, and I'm going to start doing kind of pros and cons of what we find out and what folks are experiencing in the wild when they're looking at Kops, which I was a maintainer and a contributor to. I loved this tool long ago, and it's very interesting to see how far Kubernetes has come and how much the open source ecosystem has come along the way. So hopefully we can like call some stuff out to give folks like an idea of like what folks are enjoying about it and maybe what folks would like to see differently. So I think the first one is the lag behind upstream, and we'll talk a little bit more about that in a second when we check out which version of Kops we're going to be running. Cool. So let's go back to my screen and my face. Jenny Zhang says greetings from Seattle, and Felipe says thanks. You're welcome, Felipe. Good to see you, Jenny. Okay, cool. So going back to our TGIK repo, this is another walk down memory lane for me here that I used earlier today, which was kind of exciting to use like a piece of documentation I wrote 2 years ago that was still relevant today, when I was just kind of going through getting like a Kubernetes cluster up and running with Kops. So like I told myself I wasn't going to get a cluster up and running before TGIK, that I was just going to do it all live. But I wanted just to make sure, because I remember there was some weird stuff with DNS. So I'm really glad I did it beforehand, especially because GitHub was lagging a little bit earlier, so it took me quite a while to download the Kops repo. So earlier, while I was setting up just a very simple basic cluster, just to ensure that I kind of had like the gears greased a little bit, I used this old article I wrote. And this is in one of my blogs. I really don't write on here very much anymore, but there is some good stuff in here for folks who use Kubernetes, or a lot of folks who used to use Kubernetes 1 or 2 years ago, and I was really contributing heavily to this blog. But if you scroll down, there's this really cool handy definition of all these flags here. And we're actually going to be using some of these flags today if we get a Kubernetes cluster up and running with Kops. The good news is because of the guarantee behind the CLI flags as an API, these are all still relevant. So it's really cool. And then do I have a date on here? I want to see like when I published this thing. December 7th, 2016. Still relevant, 2018. So this is exciting. So yeah, there's a good blog. It's an ancient version of Kops, which is like 1.4 or 1.5 when I first started contributing to Kubernetes. So some of it may not be relevant, but the flags still definitely are good. The next bit I wanted to talk about is Kubicorn, which kind of does some of the pros and cons stuff that I started here on the notepad. And you can come through and you can sort of see the differences between Kubicorn and Kops. And this was, as a reminder for folks, one of my big reasons for moving away from Kops was I had some things I wanted to see differently. So I started Kubicorn, and a lot of the work I'm doing in Kubicorn is now translating to the cluster API repo that we looked at earlier. They're kind of solving the same problem in the same way, just in a different code base. And I think we're going to transition some of our code from Kubicorn into the cluster API repo. So anyway, there's some article on that if you want to find out more. Another big update is Kubernetes turned, I think Kubernetes turned 3 today. And there was some back and forth online about whether or not Kubernetes turned 3 or 4. Last week, or earlier this week at OSCON, we did like a birthday party thing. We had this really awesome cake. We sang happy birthday to Kubernetes, and somebody pointed out that we said happy 3rd birthday to Kubernetes. And if you look, it says here the initial release was June 7th, 2014, 4 years ago. So folks were like, was it 4 years old or is it 3 years old? And what we found out is we are actually basing our birthday off of version 1.0. So let's see if I can find. Let's do 1.0. Kubernetes version 1.0 was released on July 21st, 2015. So, according to Wikipedia, that means Kubernetes technically turns 3 tomorrow on July 21st. So the birthday party this week was for the 3rd birthday of the Kubernetes 1.0 release, which is interesting if you think about it. We're still on the same higher level semantic version 1 from 3 years ago, going from 1.0 to 1.11 that we're on now. So exciting to see how far Kubernetes has come in such a short time. So happy birthday, Kubernetes. So that is that link. Oh, and then here you can see this is another thing that happened at OSCON. Lamati, this is kind of relevant to your 3 things you asked about earlier. There was like this most impact award. Again, I didn't even have a badge to get into the speaking area, so this is just like me hearing about it on Twitter and other folks. But it looks like Kubernetes won the most impact award this week at OSCON, and here's a picture of some familiar faces in the industry up there to accept the award. So congratulations to both them for winning most impact and for turning 3. We love Kubernetes, and we love all the folks here in the community who work on Kubernetes. So let's jump into our quick Golang lesson for the day. This one's going to be really quick, but it's pretty cool. And there's a kind of an interesting story about why I picked this one for today's episode. So we're going to be talking about shadowing in Go today, and how to some users it might not make sense if you don't go out of your way to spend a few minutes to kind of think about it before you jump into your source code. Because you could see these patterns that we see here spread across much longer lines of code, and then it can kind of be confusing or frustrating if you don't really see what's actually happening because you're so far separated from the actual line that is up above in the code that's impacting your line down below in the code. And real quick, I see folks in chat, so let's do a quick chat update before we go any deeper there. It's Joe Thompson says, biggest con of Kops for me has it's always been AWS specificity. As I understand, it was originally intended to be multi-cloud capable. +1, Joe, another big reason for my inspiration to start the Kubicorn project that has kind of also come to a grinding halt. And I'm going to add that one to our list here. Kops does a fantastic job about deploying a lot of different types of clusters on AWS, so long that you agree with how Kops is doing it. But I haven't really seen very many working examples of the implementation that allegedly exists for Google or any of the other clouds. I know there's been work for VMware. I kind of helped for that for a bit. But again, I haven't really seen that same user experience of like type a command and poof, I get a cluster that I see on AWS. So totally agree. It would be nice to see other clouds implemented there as well. And when we talk about the cluster API and the Kops API, we're going to learn why a lot of this is important and relevant, and why this abstraction that Kops started with really translates into the cluster API that we see today and the lessons we learned along the way. So I'm going to write down multi-cloud implementations. I'm going to say no multi-cloud implementations, or a few. Actually, let's do few. That's more accurate. Okay, cool. So anyway, back in our Go program here, we have 3 chunks that we should concern ourselves with, and I'll kind of like draw a little line around each chunk here. So here's our first one, and that's going to stop there. And we'll get some white space, and we'll have another one here, and we'll scoot over, do that, and then we'll come down, and this last one here is whole new scope, and we'll just put a line here, and we'll come down here and put a line here. So you can kind of start to mentally see like the 3 pieces we're going to be talking about today and how they're going to impact each other, which this is very interesting in Golang because we're effectively impacting code here on line 26 from what happens here on line 13. And there's a possibility if we change line 13, line 26 may no longer be syntactically valid. So this line is very dependent on this line. And what I wanted to point out is in this first line, we are doing like a lazy assign, this implicit assign to the error variable, ERR, which is of type interface error, which we all know JSON Marshall, if you pull up the docs here, it's going to return a slice of bytes and an error, a regular old Go error. So what we're doing here is we're using this colon here to create error and create bytes and then assign them to the value that JSON Marshall returns. And in this case, all we're doing is we're just marshalling an empty JSON object. So we know it's going to work, and we're going to get nil for an error, but it's still going to be valid code that returns a valid error, even though it's nil. So in this case, we have if error not equal to nil, just log a fatal error and kill the program, and then print out the amount of bytes, which should be 4 for the string we've defined here. So what's interesting is here we repeat the exact same code again down on line 24 and 25, but in this case we don't have to add this colon here. And in fact, if I add it and I try to run this, it's going to yell at me and say this variable's already been defined. And it says no new variables on the left side of this. So what's happening here is we're telling the Go compiler that we would like to create and assign error in bytes, But in this case, this doesn't work because we have already created the variable error and the variable bytes. Because error is a second class to bytes, we're only concerning ourselves with the second argument here, and we can get around that by removing the colon and just doing a reassign instead of an assign and create. So we run this again, our program works. Now what's interesting is if I was to comment out these lines of code, and perhaps maybe the code changed or there was another patch or something happened upstream that I didn't know about, I could try to rerun my program again, and in this case we get a lot of errors. So just by simply mutating the lines above, we're breaking behavior of code downstream. So this is really simple if you see it here in this example, but I can't tell you how many times I see Go programmers not understanding shadowing and not understanding why you have to assign in some cases and not in the other, and it's very confusing. And last but not least, this is a trick that I didn't even know existed until I started contributing to Kops, which was you can actually define a whole new scope in the Go programming language just by doing an empty set of curly braces here. So in this case, we have a new scope, which means the variables are defined only within that scope, so we can actually have to do a create and assign all over again because we're in a new scope, and this error is technically different than this error. So that's why this program here is valid. So in Kops, you'll notice in the source code, you'll see these large chunks of code wrapped in these empty curly braces that all they do is just define a new scope so that we can copy and paste code easily throughout the program, which you see that a lot in the internals of the Kops source tree. I have no idea what the source code looks like anymore, but this is just a heads up. So anyway, if you run this again, you should see we get 444. So quick and dirty lesson on errors and return types and shadowing and scope in the Go programming language, and just be aware of this as you're working in other Go programs. So that is our Go 101 lesson of the day. Let's see, how do I go back? Oh, these are all new pages. Let's go forward. And episode 43. Okay, cool. Let's see what folks are saying in chat. We're already 23 minutes into the episode, and then we're going to start playing with Kops and talking about the source code and seeing what we can do here. So we have good evening from Russia. Jason Morgan says, does Kops or kubecorn/cluster API do any configuration of the clusters it creates, like what you see with GKE where it disables exec into the privileged containers? So Jason, the way that, and we're going to look at this in Kops and kubecorn and potentially the cluster API, we're still kind of talking about it now, but the way that all three, or two, possibly three of those tools solve configuring any node is first we provision the node with like a cloud init system or style system, which is basically, you can think of it as a bash script that runs on startup. And then after that bash script runs, the idea is that whatever the bash script executes should be responsible for configuring your cluster. As far as like arbitrary one-offs of like, I want to turn on this API server flag or turn this API server flag off, the way Kops and the way that kubecorn do it are very different. Kubecorn gives you YOLO, write whatever you want. We're just going to run your bash blindly access to configuring your Kubernetes bootstrap with kubeadmin, whereas Kops has a whole different mechanism for passing API flags through to node up, which is how Kops bootstraps clusters. So actually, that's a really good point. If we go over here to our dock camera, we're going to draw another line, and we're going to do, this one is Kops, and this is going to be kubeadmin, and this is going to be Kops over here. And we can talk pros and cons. Actually, I'm going to call this one node up, which is going to be Kops' version of bootstrapping a Kubernetes cluster. So, interesting piece of trivia, the whole reason node up existed was because Kops existed before kubeadmin was really a mature project. Now that kubeadmin's a mature project, I was able to create kubecorn and actually bootstrap Kubernetes sort of a more official way using kubeadmin. Kops traditionally uses node up, and I think bits and pieces of kubeadmin along the way as well. And we can look at some of the differences of how those two things bootstrap side by side. We're actually going to go look at a Kops Cloud init script and actually look at the node up binary on a node after we create a cluster in AWS. So great question, Jason. Lamati. Kris, if you get a second, can you compare and contrast Kops, kubecorn, kubeadmin, kubespray, etc. for provisioning new clusters? Super curious to see where you see each tool being used. I definitely can do that. The question is whether or not if I should do that, because that could very well take quite some time. How about I do a really quick high level, just of my personal opinion of these tools, and then we can maybe do another episode or drill down into some of the nitty gritty later. Like I kind of want to do like a really deep dive into kubeadmin at some point. in the future as well. But real quick, off the cuff, I should say. So the question was Kops, Kubecorn, Kubeadmin, and Kubespray. So right away, I'm going to just throw Kubespray out. I haven't really worked with it. I kind of know what it does, and I cannot speak intelligently about it and how it solves the problem. I know that Kubespray does have multiple cloud implementations, but it's just a matter of figuring out which ones. So Kops is a command line tool. It's API driven. It uses a unique API. Kubecorn is also a command line tool. It's API driven. It uses a unique API. So the Kubecorn API and the Kops API are different, and that was kind of the inspiration for the cluster API, which aims to be like the community standard API. And all I mean when I say API is the configuration file for how you would express a Kubernetes cluster. A really great example is Kops has instance groups, and Kubecorn has server pools, I think is what we called it. And Cluster API has machines. So 3 different words for the same concept, pretty much. But either way, when you actually look at defining that as a struct in the Go programming language, having different words there can sometimes be a problem. And then, of course, there's like small differences between what Kops defines and what Kubecorn defines and what we care about and what we don't care about and what we want to plumb through and what we don't want to plumb through. So fundamentally, the API of how a user would interact with any of these tools is very different across the board. As far as scope of work goes, I think Kops and Kubecorn have a relatively similar scope. I think Kops is focused a little more on like the enterprise experience. Kubecorn is kind of like YOLO, you can do whatever you want. And then Kubeadmin very firmly said, we're not going to care about provisioning infrastructure. We're only going to care about provisioning the Kubernetes bits that run on top of infrastructure that you create outside of our tool. So Kops does both start Kubernetes and bootstrap infrastructure. Kubecorn does both, start Kubernetes and bootstrap infrastructure, and Kubeadmin does not bootstrap infrastructure, it only bootstraps Kubernetes. So hopefully that makes sense there. And I'm going to have to move on. And like I said, we can talk more about that a little bit later, Lamati, if you still have questions. Let's see, there's some questions between Lamati and Pablo. Justin said, never fully grokked some of the benefits of that. Thanks, super helpful. Lamati says, also shadowing explanation. Marco, good to see you. Jason Morgan says, super cool. Awesome. Okay, so, I think we're done with our intros. I'm going to grab some club soda, and then we're going to look at Kops. So, how do we want to do this? Let's jump in our terminal. This is me committing up to TGIK. I'm in the TGIK directory right now. I'm actually going to do this with one hand and drink at the same time because I'm so good at one-handed typing from my climbing accident. Let's see where we are. We are in TGIK, so let's go into episodes. And we want to go to 043. And if we have any notes along the way, we can take them here in this directory we created earlier. So the first thing we want to do is let's talk about how I got the Kops binary. So what I did is I went into my Go path, I went to source, I created this directory, I typed, make-dir kates.io, which I'm not going to run that, although it'll look like I'll run it, but I'm really going to just cancel out of this. And then I went into kates.io and I ran this git command. I did git clone, git at github.com, Kubernetes kops.git. And this should yell at me because it already exists, but that is how I cloned it, and then I went into the Kops directory, and I usually will do a git remote remove origin, git remote add origin, git at github.com. This is going to be my fork, Kris Nova /kops.git, and I'll do git remote add origin, git at github.com. Kubernetes /kops.git, and I don't want origin, I want this one to be upstream. So let's change this. And I have a tool called clone that'll do everything I just typed for you, but so you see it expressively, here's how I would get ready to start contributing to Kops. So come in here, and then again, like I remember working on this make file forever ago, but I just typed make and kind of hoped for the best. And sure enough, it worked. So I can now type Kops. It's in my Go bin, so it's in my path, and we're off to the races. We're playing with Kops from master right now. let's talk about how you would do that if you weren't a Kops maintainer or contributor from 2 years ago. What I would have done is I would have come here, and I would have gone to github.com/kubernetes/kops. And here we have releases. And you can come through, and you can see Justin's been doing a really good job at keeping up with these. And we just got a 1.10 alpha, and you can download the binaries here and stick them in your path. Sean Smith says, hey everyone, hope everyone had a good week. And Doug brought up another good point, which is also just brew install Kops. Doug, just out of habit, I usually try not to brew install anything unless I can't get it any other way. A lot of the stuff I'm going to be doing and saying today, you guys are going to have to keep me honest. I'm doing because of like old lessons learned the hard way that I don't really even think about anymore. So if ever I jump ahead and you're like, why did she do that? Just drop something in chat and I'm happy to explain why. I just knew that we release statically linked binaries here in the releases whenever we do a release, so I just knew I could come here and grab one if I needed to as well. The reason I even checked out Kops and built it was in case we come across any issues that we decide to fix here live during TGIK, and also because I want to be able to look at the code and maybe put some debugging in a little bit later when we actually look how Kops reconciles infrastructure. And if you read my book, you know that I came up with this thing called the reconciler pattern, which a lot of that came from work in Terraform and work in here at Kops, and you see some of it in Kubicorn. And now it's really evolved into this even more mature pattern that you see in the cluster API. So we're going to kind of go back here in time and see, like, you know, where did this whole thing start from, and then how is it different now, and then more importantly, why technically did we decide to move forward and make it different? Like, what was our inspiration? And we can see some of those original concerns here as well. Okay, so that's why I'm doing things this way. Nicholas, Git remote rename. Thank you, Nicholas, for that wonderful Git tip. I didn't realize you could do Git remote rename. I always just deleted and recreated out of habit, but that's good to know. So we have the Kops binary checked out, and real quick, I want to jump back in my terminal and like make sure I don't have anything defined. So when I first did a Kops create cluster, I was astonished, absolutely astonished, because it worked on the first time. And then I remembered that I had this really fancy bash RC I wrote a couple of years ago that, because I got so frustrated with always having to reconfigure my Kops environment every time I wanted to create a cluster. So I went through and I commented out all of that code in my bash RC so that we would have to kind of go through the setup process again. And it took me a little bit of like fighting with it, but I finally was able to get a cluster up and running, and we're going to kind of go through everything we can other than just straight up buying a DNS name that I think you need, or at least I know you used to need, and I don't know how to create a Kops cluster without a DNS name off the top of my head. I'm sure we can try to figure it out if folks want to see it, but I went ahead and bought one, and I already did that before the episode as well, because you have to wait for domain propagation and registrar stuff and all that fun DNS noise. So anyway, I picked up TGIK8s.com earlier today, and we're going to be using that for a demo. So the first thing I did after not running this program in some time was I just typed Kops, and I started to kind of read through. And like I remember when I went through and capitalized all of these words one day because they drove me crazy. So you're welcome for that, everybody. They're capital now. They used to be mismatched. And good old create, and we have describe, and we have delete. And these all look pretty much the same as they did when I last worked with the program. So nothing really new jumped off the page at me. I think one of the last things I remember was this toolbox command was like just barely coming in. And I always kind of thought of this as like the junk drawer of Kops. Like there's like stuff in here that like we don't really know where else to put it, but it may or may not be a good idea, and we're figuring out if we're going to use it or not. And then we have create, and there's update and upgrade. So these to a new user and even to me still are a bit confusing, but it does matter which order you do these in, and they do have different paradigms behind them. And then also we have rolling update as well. So we can look at those as well as we get a Kubernetes cluster up and running. So the first thing we want to do is we want to create, let's see here, a concept of a cluster. So this is very similar to how Kubicorn creates the concept of a cluster. Hello, Tex and Raj. Hello from Houston. Good to see you. So how Kops and Kubicorn create clusters are similar in some ways and different in others. So Kops will, by default, we're using AWS, attempt to store the cluster definition in S3. Kubernetes supports multiple data stores, and the cluster API uses it uses an aggregate API server today, but hopefully CRDs in the future, which is a fancy way of saying it stores that cluster representation in Kubernetes itself, which is a huge, powerful win for the cluster API project, because in both Kops and Kubernetes, we are sort of pulling ourselves away from the Kubernetes cluster. So anyway, what we want to do to create a cluster is, oh no, I just typed Kubernetes. Oops. Kops create, and we can just run this, and I'll just kind of go through the commands here so folks can see them. It says Kops create, there's some examples here, and we want to create a cluster in Amazon, which is this little bit here. And then it gives you some example flags you can use, and we can talk more about what all this means later, because we're just going to do a simple one to start, and then maybe we'll do a little more complex example later on in the episode. So, Kops create cluster, and without any arguments, let's see what happens here. -- name is required. So this is telling us that we need to pass in this flag. So let's do TGI live, which is what I usually use when I'm creating a Kubernetes cluster. And I guess, I don't know, should I jump into the source code yet? I think I should wait. I think let's create a cluster and then do source code. And we can talk about where all this flag validation is coming from and why that was a concern for me as a software engineer, maybe a little bit later. So yeah, let's just create a cluster first and we'll do source later. So anyway, so let's do Kops create cluster -- name TGI live. Oh no, we got this error. Statestore required value, please set the -- state flag or export the Kops statestore environmental variable. And it says a valid value follows the format s3:// and then the name of some bucket. And you need some sort of S3 bucket in order for us to store our cluster information in. So we have a dependency on S3 if we just try to run it as the user would naturally without going through the documentation. And we can remedy that by, let's pull up Chrome. Let's jump into Amazon. Let's see, where is my Amazon? Amazon, AWS Engineer. We want to go to S3, and we're going to create a new bucket just for today. So we have like an empty one, and I'll delete it later. We're going to call it Kris Nova Mountain TGIK. The reason I put mountain in there is because it needs to be a unique string, and I really doubt anybody's done Kris Nova Mountain TGIK before, because those are all pretty weird strings to have together, unless you're me. Okay, so next we'll just do all the default values here, and poof, we have an S3 bucket. So Kris Nova Mountain TGIK. So now let's go back to our terminal, and let's do export. What is it? Kops statestore here. So Kops statestore equals s3:/ Kris Nova Mountain TGIK. And real quick, we have a comment. Elisiano, Kops toolbox is useful for templates. Real quick, Elisiano, what do you mean by templates? I can take a look a little bit later on in the episode, but curious if you can give a little bit more detail there on what type of templates you're referring to and what maybe would be a good example of templates for folks to look at that I can maybe run through would be helpful. Okay, so we have Kops statestore is equal to Kris Nova Mountain TGIK, and let's run our Kops create command again. Another great Unix one-liner. I always like to sneak these in whenever I can. A lot of folks will use clear to clear their screen. And if you didn't know, at the end of a line, if you don't want to issue it and you want it just to look kind of like you did, it's really handy for demos. You can just hit Control-C at the end of the line, and it just looks like you typed it, but you didn't. But if you had spent a lot of time typing a command like I did here, and you still wanted to clear your screen before you ran your command, this is really handy for demos when you want to show a nice clean output from a command you ran. While you have text in the terminal buffer here, you can hit Control-L for Control Lucy, and it'll clear your buffer without having to impact what you have in your buffer. So you can go Control-L, I still have my command there. I do this a lot during TGIK. And sometimes I do it so fast folks don't even realize I'm doing it. But that's a handy command to be able to clear your screen without having to delete what you're typing. And you can do that mid-typing. I'm just hitting Control-L over and over here. Okay, so Kops create cluster minus name TGIK live. Poof. Must specify zones or cloud. This is where we get some good old Kops implicity going on here. So again, this just comes from me looking at the source code and writing some of this and being a part of it for so long. What's actually happening here is Kops is saying you must specify an AWS availability zone. So if we go into Google Chrome, we can go back to our EC2. Command K also does that. It says ashish. And the reason I don't do Command K is because in Emacs that does delete line. And I have some Emacs shortcuts in my terminal as well. Wow, really? You guys didn't know about Control L? I use that all the time. Wow, okay. Well, Control L will totally clear your screen without you having to type clear. Wow, I didn't realize folks didn't know that one. Do you know about Control E and Control A too? Because we should just do those really quick. If you're in a terminal, and this all comes from Emacs, which is why I know about it, because Emacs is the best text editor, and you have a command you type in, you can do Control A to get to the beginning of the line. I remember it because A is in the beginning of the alphabet, and then Control E to get to the end of the line, and I remember E for the end of the alphabet. So you can easily get to the beginning and end of the lines that way, and you can clear your screen as well while using your handy-dandy control commands. Okay, so what was I doing? I lost my train of thought. Oh, we were talking about availability zones. So here in Amazon, for folks that don't know, whenever you create an instance, let's just start this instance creation process. You can create, I don't want to launch it just yet. Okay, maybe this is not the best way to show it. Let's just look at what we already have running. So here's a Kubernetes cluster I have. I think this is not Kubicorn. This is Heptio Quick Start. Yeah. We have, let's see here, US West 2B. So we're in the US West 2 region, which is Oregon here, and then we have A, B, and C, which are different availability zones. And that says in this region, we have availability zones that have different fault concerns. So there's some guarantees around if one zone goes down, the other ones will remain up. So it's always a good idea, especially in Kubernetes or anytime you're running a system, if you can distribute your distributed system across availability zones, that's handy. Let's see what folks are saying. Leonardo says Cloud AWS. We're going to get to Cloud AWS in a second. There's some more Kops simplicity going on around that command I wanted to point out. Engine says, does Kops have support for bare metal? Not really. Not anything that is going to give you even close to the same user experience. Joe Thompson says, Control L sometimes clears your terminal by scrolling up one screen so you can count on it clearing sensitive info. And Marco says, what? This is awesome. Control commands in the terminal. They're awesome. You should use them. Okay, so we have different availability zones here. So in Kops, if you do -- zones, and you can do, it's a CSV here, common or separated values, and you can name an availability zone. In this case, I'm just going to name one, and that's going to tell Kops to create a non-highly available cluster in just one zone. If we listed more than one zone, we would get a highly available cluster distributed across multiple zones. And that's the implicity in Kops. There's not a -- HA flag. It just looks up. If you actually look in the source code, it'll do a length on your zones here, and if it's more than one, it'll just switch over to HA mode. So weird implicity. If you're not familiar with it, it's not very concrete. If you don't know exactly what we mean here. So laws. I'm really bad with names. Elciano says, so with Kops, you can define a cluster in a template file using Go template syntax. And then you can have one cluster definition and then do variables defined for files. Okay, so I think what they're saying is we can create arbitrary Kops clusters and use the toolbox command to sort of express more of our cluster that Kops would give you out of the box. And we're going to talk more about how Kops tells you which AMI to use and how there's a lot of things you can't really configure in Kops later. So Doug says US West 2B, and Ashish says, is the zones only for when workers or for master nodes as well? That's a good question. I know this is how we define how the masters are going to be separated, and I think nodes by default are just going to come up using some sort of round-robin algorithm along the way. So anyway, we're going to specify one zone just to create the world's simplest Kubernetes cluster, and we're going to run this, and it should yell at us. And it says, unable to find cloud provider in zones. So that's where this -- cloud comes from. And what's interesting here, and this is just weird behavior in Kops, is if you were to actually specify a valid name here, which in our case is tgikates.com, I kind of purposely picked an invalid name to kind of show off this behavior. if you do tgikades.com and you pass it in zones, Kops should just automatically be able to detect that you're using AWS. The reason that our name was invalid is because with Kops you either needed to pass in a domain name or you have to call your cluster an actual valid domain name. And actually, I'll do it later. Otherwise, it's not going to work. So Kops has a hard dependency on DNS, at least out of the box. So I'm going to add that as our third con here. That, again, was a big inspiration for Kubicorn. Hard dependency on DNS. Typo in US West 2B. Okay. Thank you for pointing that out, Ashish. Thank you, Christopher Cruz. And then more people are talking about Linux commands, so I'm going to let you folks have your own conversation. Okay, and so I bet actually it has nothing to do with the name. Let's change this back to an invalid name, and I bet it still will imply AWS. Let's see. Yeah, so it says inferred cloud AWS from zone US West 2B, and then it says invalid value TGI Kades live. Cluster name must be a fully qualified DNS name. So let's go back. Oh, I'm like clicking in my OBS screen, not in my regular screen. So let's do this command, and instead of doing TGI Kades live, let's do our real domain tgikades.com that we have here in Route 53. So a lot of configuring goes into this, and if you haven't done this before, it's kind of a pain. But I'm giving you the quick and dirty overview. And a lot of the work that we're doing in Cluster API is sort of like inspired by some of the lessons we kind of learned the long way and doing this in tools like Kops and Kubicorn. So let's see, how do I get to Route 53? Here's Route 53. And we want to go to hosted zones and tgikades.com. So I bought this one. And if you notice, there's some weird stuff going on, which I have this, why is this weird? I have this record set here. How do I delete this? I don't know why it's like scooted over so far. I added the default Google DNS A record to our domain because Kops does a DNS lookup every time and will break unless you have something registered there other than just your name servers. So as we wait for DNS to propagate, we're going to roll the dice. We may or may not get a valid Kops create cluster command because it's going to do a DNS lookup. And how I know that is if we jump into the source code here. I know I said we were going to look at source code later, but I can't help myself. I just have to pull up the Kops source code. Okay, go, source, kades.io, Kops. Open. Usually I zoom in here, so let's do that. Let's do tool windows. No, wait, I want to do presentation mode. How do I go back? Let's exit presentation mode and try this again. Exit presentation mode, minimize TGIK. Where did I go with Kops? Is it here? No, let's try to open this thing again. I don't know where that screen went. Go. Source, kades.io, Kops. Oh, here it is. Oh, it opened up in like full screen in a different pane. Okay, so now let's go to view, enter presentation mode. Ah, it did it again. This is weird, I'm struggling here, guys. Give me 1 second. There we go. Bam, bam, now I can resize. Awesome. And we can file open. Last time I promise. Go, source, kades.io, Kops. Wow, my IDE is just not wanting to cooperate today. Let's close this and start over. Is it not there? I don't know what's going on. Okay, either way, we can look at the source code later. I can always do it in Emacs as well. But if we actually run the command without seeing the DNS lookup into the source code, we can actually see that Kops should yell at us here. So it'll infer the cloud, previewing changes that will be made. Nope, it still was able to look it up. So the fact that I had a DNS record before seemed to trickle through DNS still. It didn't repropagate. And we were actually able to create a concept of our first cluster here. So let's get GoLand out of the way. And let's go up and see what happened here. So if we scroll all the way up, we have like this lovely like output here. Let's see where it starts. Okay, so we like create these tasks, which are just arbitrary like resource mapping to this API definition that we are completely blind to at this point. And then it like spits out all of these like concrete resources in Amazon that we're going to create, and then all of the values for them as well. And so what really happened behind the scenes, and I remember like when I first started using it, I was kind of frustrated because I didn't really understand how we got to the resources from that first command, or even why we did the first command that way. But if you actually see what Kops is doing, it actually makes a little bit of sense, and I think Kubicorn kind of simplified it a little bit, and Cluster API takes it a step further and sticks it in a CRD or an aggregated API server and makes it even simpler and a little more like declarative in nature, following Kubernetes paradigms with like having a proper spec and a proper status and so on and so forth. But if we go to S3, remember we had to configure an S3 bucket earlier. Let's see, S3, Kris Nova, Mountain TGI K. We can see that our Kops cluster TGI.k.com now has cluster spec. If I click on cluster spec, can I open this? Pop-up blocked. So what do I control open it? Command open it? How do I want to disable pop-ups on this page. Where's my pop-up blocker? Okay, maybe I can just download it and open it here. So, cat, it's in downloads. Cluster.spec. So here's a YAML file. And this is, if you've worked with Kubicorn before, this having a YAML representation of your cluster is a really cool, important thing. And you get it on your local file system by default instead of S3. And if you look here, this is just a good old Kubernetes object. And you can see we have like all kinds of configuration bits here. We have API, we have etcd configuration, etcd members. Jason, earlier you asked about configuring your cluster. Here is sort of an example of how you would plumb through some of these configuration options into your Kubernetes control plane. Here's our Kube API server. We have, allow privileged, and like Kops makes a lot of assumptions for you here. Some of these assumptions may or may not be relevant or smart if you aren't sure what you're actually doing here. So this is a very intimate decision. It's like configuring your Kubernetes API server is like picking out a car. Like that's between you and your family, and you're going to have your own specific concerns. Like, do you want the heated seats or not? So by default, it's nice that it gives us a little bit of a good sanity check here, but I still would encourage folks to come through and actually look at what's going on here and make sure that we're actually following Kubernetes best practices. This was a bit that was flipped a while ago that caused some problems downstream, and the allow privilege true bit is another interesting one as well. I'm not a control plane expert, but I have heard some concerns come up around the default configuration here as well. So as we scroll down, you can see we have SSH open to everyone in the world. Kops did some math behind the scenes to generate a CIDR address for us. I think I remember working on that function. It would be really fun to go look at that function because that was a really hard function to write, because CIDR addresses are really hard to calculate, and there was some cool logic there. And I remember working on that, but my IDE doesn't seem to be wanting to cooperate, so we can skip that for now. And another thing that is interesting is if we look at Kops, we can do edit. And so we can do Kops edit, TGIK, 8s.com. What happened here? Oh, Kops edit cluster, because there's different resources here. Kops edit cluster, and that kind of does the same thing that we just tried to do, but it's going to open it up in our favorite text editor, Emacs. And we're going to scroll down, and we can see everything we just looked at that I catted out to the terminal here. And what's cool is, like, if I wanted to, like, let's make an easy change, something that I know that's not going to break anything. What can I change here? Topology, public. Okay, so the topology stuff we'll get into a little bit later, but that's another feature that I contributed, and there's different ways you can configure your Kubernetes network with Kops. I have not seen anything that looks super harmless to change right now, so we're just going to keep it as is. But if I did want to make a change, I could just save it, and it should save it and re-push it up to S3 as well. So let's see here. We have some questions here. People are saying edit IG. So yeah, let's do an edit IG. And I think there is, if we scroll up like an example, after we ran this in our output here, maybe not. Where was all of our, yeah, here we go. Okay, so this is our create command. I think the edit IG should be here in this output. If we scroll down, nope, too far. Suggestion, edit your instance group with Kops edit IG. This is what we want here. So this should be easy to change. So if we edit IG and we tell it the name of the IG, which is instance group is nodes, we can actually come in here, and this is another Kubernetes object. Again, in the cluster API, we would see something like this being stored in a Kubernetes cluster instead of S3. And you can come through and we can change our max size here. Let's just bump it up to 4, and our min size, we'll bump that up to 4. So now we're going to get a Kubernetes cluster of 4 nodes. Okay, and so that pushed it up to S3, and if we go back to S3, I bet we can come in here, and we can look in instance group, and if we look in nodes, let's see, how do I open? I really want to just open this, but my pop-up keeps getting blocked. Where's my pop-up blocker? I really want to find this thing. I think it's got to be control. No, that's like the color picker. This is just annoying. Maybe option click? Control click? Nope. Command click? I can't figure it out. If anybody wants to Google how to override a pop-up blocker, that'd be handy. But anyway, if we came in here and we looked at it, we could actually see that our change had reflected through to S3, but I'm not going to download it and open it up again because that's just going to take time. Okay, so this is where we get into the actual update part of our reconciliation. Now this is interesting because we're effectively doing one iteration of a control loop, and when I kind of imagined this in Kubicorn, I actually put this into a proper control loop. Instead of sort of doing this linearly like we see in the Kops source code. And the reason for that was because even on first deploy, if something went wrong, we could undo ourselves, or we would just repeat the loop again and try to fix it. So in this example, we're going to turn verbosity all the way up, and we're going to actually see Kops doing some of its reconciliation stuff. And that's going to sort of be like a really exciting point where we learn about like control loops in general and see where an infrastructure control loop we sort of started to get the idea from. So we're going to do Kops update cluster -- name TGI Kubernetes.com. And let's see what was next. I want to do -- yes, and I want to do -v10. I think the syntax is right. It's been like a year and a half since I've done this. So let's see what happens here. All right, okay, ton of verbose output here, and this is what we wanted to see. Very good. Okay, so if we scroll up, we see all kinds of stuff happening. Kops is making all kinds of assertions. It's hitting the Kubernetes API. It's spitting out like raw objects to us. Like we just got the full like master dump of everything that was in memory as the Kops program was executing. And the reason we did this is because I wanted to kind of like call out a few things. It's like, first we're creating a private key, we're creating different infrastructure, and we're bootstrapping our cluster along the way here. So we're calling S3, and you can see that really there's this cloud dependency baked into the way Kops works on day one. Like it's calling S3, we're making API calls, we're writing files to S3, we're putting objects back in S3, we're listing objects, we're doing all kinds of stuff here. And when it's all said and done with, we can scroll all the way down to the bottom here, we see that we get, well, multiple lines because we have verbosity turned all the way up, but we see that we've created some certificates, and we've regenerated our kube config, and we set our kubectl context to tgikates.com. Now, I wanted to point this out because this is a discussion that we're having in upstream in the cluster API today, which is how do we, as a community, if we are really going to start to standardize on this stuff, how do we handle creating auth material? On one hand, we do it like we just see Kops, which is, by the way, Kops is lightning fast. This was really quick because we generated the certs and then threw the ball over the fence, and now if something breaks, we're completely blind to it. But it was really fast because we did all the work here, and then we like pushed everything up to the cluster and said, okay, cluster, now you have everything you need. Go figure your own stuff out. Kubicorn does it a different way, and we generate all of our auth material after we've created infrastructure. So in order for us to generate auth, we first have to create a virtual machine. So there's a little bit of a lag in how you create a kubicorn cluster. If you've ever created a kubicorn cluster or watched the TGI on it, you know that it takes about 2 or 3 minutes, whereas Kops was like 30 seconds or so. I don't know, I didn't do a time on it, but significantly quicker. Mauve says, oh, it's next to the star button. Oh, heck yeah, thanks folks. We'll get that again in a second. I think I see the star button, but we'll find out. So anyway, Kops generated the certs, and then because we generated the certs locally, we were able to build our kube config on day 1. And if you don't know the way Kubernetes works, let's talk about certs in Kubernetes. Let's go to our dot camera. I'm going to get our pros and cons out of the way. I can already tell this is going to be a longer episode, so like happy Friday if you folks want to go get like a beer or something. Like I'm going to be ranting about Kops and Kubernetes and infrastructure for a little bit. Okay, so we want to talk about certs in Kubernetes. So Kops created a handful of certs here. It looks like 1, 2, 3, 4, 5, 6, 7, 8, or 9 of them. But the 2 main ones that I kind of want folks to understand are the API server, which we're going to do API server. And this is going to have a layer of TLS on it by default. And again, you can use like whatever auth you want. In this case, we're just doing TLS. And then we have a kubelet, which also has TLS. That's different than the API server TLS. A lot of folks don't know that. That was one of our trivia questions at the Kubernetes trivia the other night. And then we also have you, our handy-dandy person, out here in the internet trying to interact with Kubernetes. And so you, as a person, I'm going to draw like a little scroll here. This is your kube config file. We're just going to write config, CFG. Should have information that allows you to talk to this API server. And then this API server actually does a both direction. This API server goes both ways between the kubelet. So that's how that sort of transaction happens. So because we generated the certs beforehand on our end of the fence, we were then able to tell this server and ultimately this server which certs to use, and they kind of knew about each other beforehand. So there was this sort of like it solved this chicken and the egg problem and allowed a little bit quicker of a startup time for us. So this is just an interesting thing to think about. And like I said, Kubicorn, we do it a little bit differently. So I would encourage folks to start like coming up with their own opinions on which ones they like more. So anyway, in this example, our kube config is already built because we're telling the API server which certificates to use instead of waiting for the API server to tell us which ones it automatically generated, or which ones we automatically generated on the server at the time. Okay, so that's my TLS rant. Let's get back to not my face, my screen. Okay, so let's go look at Amazon and see what has happened along the way. I'm gonna type clear and not use Control-L because I didn't have anything in my buffer. And if we go to EC2, we started out with 4 instances. We now have 9. Sorry, Joe, for racking up the AWS bill. And here we have our master, and here we have an arbitrary set of nodes. Okay, so with our master, we have this public IP address. And if you remember, we looked at public and private topology. And probably the quick and dirty, if you need to know one thing about public and private topologies in Amazon using Kops, it's I can SSH directly into either the master or any of these nodes. If you notice, they all have a public IP address here directly. And in a private scenario, which this is how we do things in the Kubernetes Quick Start, it's much more secure by default. I think EKS might even do this by default as well. Kubicorn, I don't know if we do this by default or not. Marco, help me. Do we do private subnetting by default? I wrote the tool and I can't even remember. Anyway, by default, Kops will give you a public one. So a little bit more insecure. We're exposing parts of our Kubernetes cluster to the wild out of the gates, but it's okay because it makes it easy for us to kind of demo here live today. So we have a public IP address, and we can SSH directly into this. So how we're going to do that is we're going to SSH, and this is like the moment where I just know it's admin because I've done this 100 million times in the past, but it's admin at our IP address here. And now is a great chance for me to stop and talk about the ability to configure operating systems in AMIs and tools like Kops, Kubicorn, and the Cluster API. So by default, we use this AMI that is governed by Kubernetes in Kops. And if you go to what used to be the Cluster API repo is now just good old kube deploy, we have Image Builder. And this is where we're generating our AWS image from that we use for Kops. And so this is actually the AMI that we are running and about to SSH into. And this is sort of maintained by the powers that be at Kubernetes. I think, you know, we try to keep up with it as best we can. And, you know, it's there, and that's what we use. So anyway, if we SSH into our master server here, we're going to just sudo bash really quick. And we're here in our home admin. And we're going to start here in var log. OK, so here in var log, we have a ton of stuff going on. Nicholas D says, can't see your terminal, Kris. Let's see here. I'm going to give you folks a second to, like, I'm going to let the log catch back up and make sure you still can't see my terminal. Maybe do I do that? Will that help? Let's see if that helps a little bit at all. And again, I'm just going to grab some club soda and wait. Why the... Oh, Nicholas says, oh, forget about it. It's my screen. It's OK, Nicholas. No big deal. I got some club soda out of the deal, so I'm happy. Here in var log, we see a lot of stuff. We see kube proxy. We got the controller manager, the kube API server. Already, this is looking like a Kubernetes node. I'm already trying to tell Kubernetes components are running. If you've ever debugged Kubernetes before, you're like probably super familiar with this log file, maybe this log file, hopefully not this log file. And you can see here we've got some containers logs, so we think some pods are running in Kubernetes. We have etcd, so I really hope you've never had to go into that log before. But what we're going to look at today is this log here, cloud init log. So we're just going to cat this whole thing out the screen, yellow, and we're going to see what we have. So this is all cloud init stuff. And again, I know a lot of this, it's tribal knowledge, but somewhere in this file, you see this directory varlib cloud instances scripts. If I get this right on my first try, I'm going to buy myself a beer after work. Oh, I did not get it right, but I was close. Varlib cloud instances. Okay, so if we go to this directory, varlib cloud instance scripts here, we see we have this part 001 file. Now this is the actual file that Kops generated for us behind the scenes. And if we go back and we look in that huge long terminal output I had earlier, you actually see where we created this file. And if we cat this file out, we can actually see that Kops, in its deepest, darkest corners of the internet, is really just a bash script. The cloud runs on bash. So we see we have this wonderful thing here called node-up URL. So what's going on here? So Kops is pulling down a statically linked binary from this endpoint right here. And we can actually simulate this. If I were go to, oh, this isn't going to work on my Mac. I'll just copy this and I catted this out the screen so I can just clear. Yeah, so I can, do I have wget? Yeah, I do. Wget, and I'm going to download this, and you're going to see that this is actually what Kops would be doing as an instance is coming up. So we're downloading node-up. And remember earlier we talked about how Kops does infrastructure and Kubernetes provisioning. So the infrastructure bits are the actual command line tool that I was running locally on my Mac a few seconds ago. The Kubernetes bits are managed by this lesser known tool called node-up. Now node-up existed before kubeadmin was super mature, but attempts to solve some of the same problems. Now kubeadmin is definitely the preferred way of going about and bootstrapping clusters, at least in my concept and my understanding of it. It's a community-sponsored project, and we are working on it actively in SIG cluster lifecycle. And we can actually run node-up here. And just in general, the way the two tools work, I think node-up has a dependency on having certs passed into it, and it does some interesting stuff with DNS as well. Did I not get it? Oh, do I have to chmod it? I just want to run it so folks can see how the program works. So if we run node-up, we can do this, node-up. It should just start running. And it sort of runs as like this sort of cloud init only style. So it's got like built-in retries, so it's pretty resilient, which is handy. Most folks just wrap like kubeadmin in like a for loop and like kind of retry it over and over again. But if we, can I apt-get install kubeadmin? No, you have to add the repo for it. But anyway, if you actually run the kubeadmin command line tool, it's actually like a proper command line tool. It has help and like tells you about like how you can authenticate with a token and bootstrap a Kubernetes cluster. So a little bit more flexibility there, and the kubeadmin release cycle is very married to the Kubernetes release cycle. And earlier we had somebody mention one of the the parts about Kops that was hard for them was the lag between upstream and Kops. And so what they were really saying is if we pull up Google Chrome here, and we go to the Kops releases here. So we just got 1.10 alpha 29 days ago, which means that we've started a 1.10 branch of Kops, meaning Kops will support Kubernetes 1.10, but it's only an alpha, so we're not making any hard guarantees yet. So this should probably ultimately go to beta, and then we should have a stable release. And if you look down here, it looks like the most recent long-term stable is 1.9, meaning that right now, Kops can only run Kubernetes version 1.9, whereas we just had a release for Kubernetes 1.11 relatively, soon. Like, it was a relatively short while ago. So that's sort of like the lag that we're seeing here. And with Node Up, we sort of inherit that same, that delta between Kubernetes upstream and where Kops happens to be. So in this case, this version of Node Up that we just downloaded, I'm not sure if we're doing 1.10 or 1.9, but whichever version we're trying to run, we'll check in a second. Node Up is going to be married to that version as well. Okay, so anyway, let's take a look at this bash script and see what's going on here. So list cat part 001, and here's the bash script that bootstraps your Kubernetes cluster. And you can see in here we have this. Oh, I love this function. This is one of my favorite function names that I ever saw. I think Justin was the original author of this, and I still to this day have or bust functions. Basically what this thing is doing is it just does like a while true. It just tries something over and over again. There's like retry delays, and if it doesn't work, it ultimately busts or exits non-zero. So more people should write or bust functions in bash. I really like it. And basically if you come down here all the way to the end, we should see download release and node up config done. And all we've done is we've generated all of our configuration files, and we've run node up, and hopefully after we've generated a properly configured configuration file and we run node up, poof, our Kubernetes components should possibly start. And somewhere in this file, we could find another directory, which is called like install path or like install directory or something. Here's ensure install dir. What is actually install dir set to? I think it's bar cache Kubernetes install, but let's make sure that's right before we try to find it. Is it up here at the top? Yeah, install dir right here. Var cache, oh my gosh, I got it right. Var cache Kubernetes install. Okay, so let's go to this directory, and then in here, we actually see this is how node up was ran. Okay, so we have the node up binary. If we wanted to execute it, we won't do that. And then we have our cluster spec.yaml, which is downloaded from S3. Remember, we looked at our cluster spec earlier. This has got a little bit more going on inside of it. And this is actually going to be what configures node up and tells us to run. So if we go back, let's do a split screen. Let's zoom this one out, this one in, and then resize. There we go. Here on my desktop, I should be able to kubectl get nodes. So on the left, we're on our master node in Kubernetes. On our right, we're on my Mac here. You can see that we're running version 1.10.3 because I built from master, so I bet I'm running in this alpha branch that we saw for the alpha release. And you can see that we're running in Amazon, and you can see that it was configured here with node up. I don't know if node up has logs. Let's see. Is there a node up log anywhere in here? I see NTP stats. I don't see node up logs anywhere. Curious to know where those logs go. Maybe they're here in Cloud and in output. Let's try this file. Yeah, okay, so this is the node up config done. This is what we saw in that bash script earlier. So here are the logs from node up running, and it's a Go program. It's a statically linked binary, and it handles bootstrapping Kubernetes in the same way kubadmin does, just with some pretty big differences there and a little bit of lag. So if we do a kubectl get pods namespace kube system, this is where things get a little interesting. So this is a vanilla cluster. I haven't provisioned anything or installed anything on it. You can see we have this DNS controller running here. And when we first created our Kops cluster, we had to define, let's see, I want to close that. Let's go back to my terminal. No, I do want to open up Golang. Okay, we're going to spend a second while I open up Golang because I want to show you folks the DNS controller and talk about DNS and Kops a little bit more. So bear with me. And I promise we're not going to go super long today. Okay, let's see if this works. I don't know, I'm wondering if this directory is empty. Let's go to go source github.com kates, or not github.com, go source kates.io kops list. Okay, so that's there. Maybe I'm opening up the wrong kops. What am I doing here? View tool windows project. There we go. Okay, now let's go view, enter presentation mode. Enter presentation mode. Slowly come up here, get you back down, resize, and now let's do tool windows project again. And if we come in here on the left side, we have this DNS controller directory, and in here we have command, we have DNS controller, and if you've ever looked at an older controller in the Kubernetes code base, you can see here that we are following a pretty familiar Kubernetes controller pattern. So we have like some watch ingress, we have gossip seed, we have DNS. Basically what I'm seeing here is Kops has a proprietary DNS controller which manages how all the different cluster components use and interact with DNS, and uses gossip to share between them. And this runs in a Kubernetes cluster that doesn't necessarily have to run in a Kubernetes cluster. So this is a Kops-specific component that runs in kube system. And this makes all of the fun DNS stuff happen. And if you remember when we did tgikates.com earlier, if we check out my kube config, cat kube config, and then let's grep for server, so I'm not putting TLS information on the internet, you can see that our server here is actually api.tgikates.com. Now, if we created this with Kubicorn or different parts of the cluster API, we would actually just get a regular old DNS name, a regular old IP address, and then we could put a DNS name in front of it if we wanted to. So anyway, enough about how Kops kind of brings stuff up and how it's different than kubeadmin. We looked at the Kops API a little bit. I think we looked at the Kubicorn API in the past. Cluster API has a totally different thing and has different controllers, and I can probably do a whole TGIK on the cluster API moving forward. But really quick, let's see if we can't get an HA cluster spun up with Kops, just for grids here in the last couple of minutes, and then I'll do some questions at the end, and then I got to jump off here because I'm probably going to be way over time. So let's delete a Kops cluster. Kops delete cluster --name tgikates.com, and let's do v10. And then while we do this, I'm going to go kind of walk through the Kops source code a little bit, why this cluster deletes, and show some folks some interesting parts of the source code. Oh, dang. Export Kops state store equal to Kris Nova mountain TGIK. Delete. Wait, why did that not work? Unable to read state store S3 bucket. Is it TGIK? Kris Nova mountain TGIK? Is it TGIKS maybe? Let's see. S3. Kris Nova mountain TGIK. Let's just make sure that's right. I thought I typed that right. Do I have a typo? I saw somebody in chat. Oh, -- yes. Ah. Do this, and now clear the screen, rerun our Kops delete, and then -- yes. Invalid, oh, S3 : // duh. I knew that. So yeah, a little bit of configuration going on here. Okay, so now let's do our Kops delete cluster -- yes. Okay, so that's what we wanted. So the -- yes is saying not only delete the infrastructure, but also delete the concept of the cluster out of S3. If we didn't add the -- yes, we would basically have only deleted the infrastructure and still stuck with the concept of our cluster defined in S3, which is useful if you want to delete and recreate. This is why in the cluster API and in Kubicorn, we follow the same concept of declaring the cluster first in a little bit different ways, but it does give you this flexibility that if you want to mutate infrastructure, it doesn't have a hard dependency on the infrastructure being in place in order for you to retain your concept of your Kubernetes cluster. In this case, we want to nuke all the things, so let's nuke all the things. Okay, so while that deletes, let's go look at our Kops source code. I'm really excited. I've purposely not opened up some of these files just for this moment right now because I haven't looked at them in so long. So the first one I want to try to find, I think it was cloud.go or maybe, no, it was apply.go. That was the one. So I think it's in package now, and I think it's in, oh, where is this file? It used to be in up in the long ago. Is there a thing in here called up? Nope, I see, oh, up, what is this? Models, cloud up, resources, add-ons, This is all of our resources now. Okay, so we've changed quite a bit here. I wonder if there's still, there's edit. I wonder if there's an apply. I don't see apply. Where did apply.go go? That was like my favorite file ever. Okay, so anyway, here in package, we have all of these different components that we're using. What is pretty? Oh, it just makes things pretty. That's cool. Good job for having a package named pretty. But this does bring up some interesting new paradigms. The first one is we have up here, and then we have cloud up. Where did we see cloud up before? Or node up and cloud up. Here it is. There's node up. Here's up. And this is it. I'm thinking as I'm talking here, so I'm sorry if you folks are losing me. Where did it go? I really want to find apply.go. I think this is it. Okay, this is totally it. So this is the heart of Kops creating infrastructure. So if you come in here, you'll notice we have this big struct defined up here at the top, which has all of our different instance groups and models and node up information and configure information. And then we come all the way down here and we have this run command. And if you ever wondered how reconciliation works in Kops, or where the inspiration for Kubernetes came from, and then therefore the inspiration for the cluster API, a lot of that came from Terraform. A lot of the Terraform stuff came from here. A lot of it was trial and error. It's kind of this like weird hodgepodge of lessons learned in cloud native infrastructure over the past couple of years. And this is a very like important function that sort of like taught me a lot. And then I sort of thought about it and redid a lot of things when I wrote Kubernetes. But if you ever get a chance to come read this function, this is a really good one. We have a lot of different phases here now. And if we can find tasks, this is sort of like where the concept of resources in Kubernetes came from, and where I first started looking at how do we map an abstraction to actual infrastructure behind the scenes. So let's see if we can find, we have types. I want to find tasks. We have SSH keys. This is where we do like our big switch for the cloud providers. So if you're running in, if you want to see which cloud providers Kops supports, this is where we're going to find out. So we have, the first one is GCE. We have cloud provider DigitalOcean. DigitalOcean is not currently, or is very alpha, and is feature gated. So it looks like very limited support for DO. AWS, the one we're using here. I told you this was the best function in Kops. Cloud AWS, here's all of the different resources we're creating. AWS tasks. Okay, so for every cluster, we need to create all these tasks, which are basically API calls, and those are mapped here. And we have cloud provider ALI. I don't even know what ALI cloud is, but it looks like we have some support for that. We have vSphere. It says vSphere is currently alpha. Bare Metal is currently very alpha. OpenStack, looks like there's a little bit going on with OpenStack. And then if not, it says cloud provider unknown. So what this means to me is, do we have this cloud, ALI, that's currently alpha. We have AWS, which is the one we just did. We have DO, which is very alpha. TLDR, most of these are alpha, other than AWS, and I think GCE was another one that didn't say alpha right out of the bat. So anyway, if you're ever curious, no, even GCE says alpha. Alibaba Cloud, thank you, Ashish. If you were ever curious about what Kops does and doesn't support, you can't get a better answer than looking into the very heart of apply.go, the core of the reconciliation loop for cloud up, which is the infrastructure bits, and node up that we looked at earlier in the program, which is the Kubernetes bits. So anyway, as we get down here to the end, we have models, and this is this used to be done a different way using YAML, and I gave a whole presentation about this at GopherCon a couple years ago. But now we've taken the YAML and we rewrote that as models, and still kind of didn't get it quite right. And then I tried my hand at it in Kubernetes using like a resource digraphy kind of thing, kind of going back to the way Terraform solved it, and that kind of also didn't really get it right. And so now in the cluster API, we've taken a much simpler approach. We've done just very simple control loops, and we say that how you map a higher level abstraction to your specific cloud is up to you. And we don't really prescribe that. So what is happening here in Kops is we're sort of crossing the boundary that we drew in the cluster API. upstream. So, Cluster API says this is the responsibility of the controller and this is implementation detail. And here in Kops, we sort of munched that into the rest of the deployment system. And we now have to build out all of these different models where we take like a higher level concept that says like SSH, and we have to now translate that to a key pair because we're in Amazon, or Google SSH's version, or Azure's SSH's version, or whatever. So that's what these models are doing here, and it's giving us a sort of a framework for how we can interact with all these different models. And it's very verbose, and it's very like line by line. And again, you see this case where we're going from Alibaba Cloud here, we have AWS here, and it's just very manual. Like we have to build master volumes, and we have to build a load balancer, and we have a bastion, and we have to do the firewall, and we have all this logic for all the different clouds down here as well. So this is a great example of where we draw the line in Cluster API, where we did it in Kops, where we did it in Kubicorn, pros and cons to each one of those things along the way. So this is we're almost at the end of the function here. We have this thing called target, and if you run target in Kops, you can like spit out either interacting with the API, you can, I think, generate Terraform configuration, at least you used to be able to. I have a feeling this is what we were talking about earlier with generating templates. Its target is sort of another way of thinking of the output of what Kops should do. Yeah, see here, target Terraform. So this is just going to generate Terraform instead of actually calling an API for us. And if we keep scrolling down, we get down here, we run some tasks, we validate the Kops version, we do more validation, we print some stuff out, we get all the way down here to the end, and this is like the end of that function that we ran earlier when we had verbosity turned all the way up to 10. That says, congratulations, you've sort of deployed your cluster here. So anyway, apply.go, the core of the CloudUp part of bootstrapping Kubernetes. Interesting lessons. I love this file. I learned so much from it. I wouldn't be to where I am today if it wasn't for this file, but it's a very special file to me. So I'm glad we got to look at it live on TGI. So yeah, let's see if we can't get an HA cluster up and running really quick, just for grins. So we should be able to do our, and I'm going to exit out of this. Actually, that's already closed, so I'm just going to close out of it. We should be able to run, see, I just did Control-L just then. You guys didn't even notice. We should be able to run our create command again, and this time just add a few more zones. So let's find our create. And here we did US West 2A, so let's do US West 2B and US West 2C. Oh, spaces. Let's see. Let's go back and let's get rid of this space. And let's get rid of this space. And let's see what Kops does here for us. Okay, so now the CIDR. Oh, I wanted to look at the CIDR stuff earlier as well. But you see how fast that was. That was really fast. Kops is already done. Let's scroll up. Where was that CIDR stuff that we were just spitting out? I want to see it. Okay, so now because we've created different zones, we have to have different subnets, and so there's this whole networking problem that goes into it. In the cluster API, we do have explicit networks, whereas Kops reasoned about that for us, which is kind of convenient. So maybe there's this is a good example of some libraries we can start thinking about as the cluster API matures. Like maybe we need to have some sort of CIDR generation library that like does some of this like noise for us, and maybe we can get some of this code from tools like Kops or Kubicorn and bring it into the upstream cluster API work we're doing. But there's a lot of good functionality baked into this that I want to call attention to. I think it's just the way it's packaged and isn't the most interfaceable. So anyway, if we go back in the source code, let's see if I can find this off the top of my head. I might not be able to, but I want to say, I'm trying to think what I could grep for. I might not be able to pull this one off. This has been a minute since I looked at how we generate API, or not API, IP addresses. So is there an API server, feature flag, formatter, instance groups, Kops version? Not seeing anything that looks very networky. DNS, okay. Let's see if I can find it offline, and I'll add a pointer to it. But there's a really cool function that you pass in like a total CIDR range, and then you tell it how many like chunks you want, and it does all the cool like networking math for you, where it tells you how many hosts and what your subnet mask should be. And it's a really great example of like, I haven't really seen very many libraries that have that piece of functionality, and it might be good to get something like that into a library so that we can consume it for other projects as well. Okay, so let's go back and see what's going on here. It says we can list the cluster with Kops get clusters, which this is handy because this sort of was the precursor of like the cluster registry, right? Like Kops has a concept of being able to list multiple clusters, Again, it's all proprietary and married to Kops code, and there's other SIGs working in the space, but I think it's a good idea. Like, I think there is a solid use case for us to be able to say, you know, which clusters do we know about? And this is going to go and it's going to read from S3 and see which clusters we have, and it's going to spit out the zones. And if you look, this looks very similar to like a kubectl Git cluster, or like if we actually did kubectl Git machines using the cluster API, it would look and feel a little something like this, except for instead of being at the cluster level, it would be at the machine level. So this is getting a cluster. So this is kind of a cluster registry in a weird way. So yeah, we can add instance groups, we can do some other things, but what I want to do is I want to check Amazon and see how our instances are doing. And then we're going to look at our control plane and see if we have an HA control plane up and running. So, and again, you can do an HA control plane with kubeadmin. It requires a little more elbow grease, but we could totally encapsulate that elbow grease into a controller with a cluster API if we wanted to. So yeah, it looks like we have one master. Why do I only see one master? Oh, those are terminated. Did I get deployed to a different region maybe? I thought I did US West. Did I do 2A? Yeah, I did do 2A. Okay, that's why. So Nadir says something like NetAdder in Ruby is very good, does RFC 3531 subnet allocation, which is good for non-K8s infrastructure. +1, totally agree, Nader. I think, you know, if we're respecting the RFC 3531, which I don't know off the top of my head, although I feel like I probably should, I think any sort of standardized network IP library would be really handy for us to have. And I know that we solved some of these weird problems that were very specific to each cloud in Kops that I would like to see in a library as well, which is like, you know, what IP address scheme makes sense for us to use in Amazon, or even specific regions in Amazon, because we all know like US East 1, I think, is like a little bit different than all the other regions. So we're starting to get some of the cloud provider specific stuff going on there. And I think just in the cluster API, we have an opportunity to kind of like rethink and reimagine some of this. So doing it in a clean way would be like, please, 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 can we do that? So let's try US West 1. So let's go to North California. I was just there. Had a fantastic weekend. And do we not have instances here? So US West 2A. That's where I think we created this thing. Is US West 2A not California? Why do we not see any instances here? Let's, oh my gosh. You guys. Kops update cluster, TGI Kubernetes.com. We want -- name. Oh, looks like US East 1 doesn't even have capacity anymore. Shows how out of the loop I am. So Kops update cluster -- name TGIKubernetes.com -- yes. So this is actually, I was going to be like, that was really fast. But this is actually going to go and create infrastructure and bootstrap Kubernetes for us. Okay, so that's why I couldn't find any of the instances, because we hadn't created them yet. And last time we did -v10, and this time we're just going to do just regular, so we can see what a normal Kops output would look like. And again, this is like sort of like the preliminary workings of a rudimentary infrastructure controller that we would see in the tool like the cluster API that we saw in Kubicorn. And in this case, again, I'm going to reiterate this. We created the TLS, we threw it over the fence, and now everything is sort of happening behind the scenes, which is good because it gives a quick exit here. We sort of bail out quickly here, but there's a lot of what I would consider possibly abandoned work going on magically in AWS behind the scenes that we don't really have visibility into anymore. So if we go to instances, like for instance, like what if we hit a limit right now, and we weren't able to actually bring up our full cluster, and our cluster neighbor came up and we had to go through and like manually delete stuff. Like there's just pros and cons to kind of doing all of this, and I'm one who kind of prefers to do things slow and precise instead of quick and hope for the best. So now let's go back to our region here, US West. I wonder if we're going to see them here. Yes, we do. So yeah, okay, so now we have a master in US West 2A and US 2B, and I bet we're going to see one in US West 2C very soon. And these are all created using autoscale groups, which is how we were able to do this so quickly, was we created the autoscale group, and then we just changed it from 2 to 1 and so on and so forth. So let's go back here and see if we can't do kubectl get nodes. We're still hanging. So the API server hasn't even come up yet. So let's see if we can see any of this live. I bet I could be fast enough. So let's grab a public IP address. SSH admin at public IP address. It would be cool if we could actually see node up bootstrapping this live. Sudo bash, clear a screen, tail -f var log, cloud init output.log. Did we make it in time? Let's see. Restarting service, Kops configuration service. I'm wondering if this is actually going to do anything, or if we... Nope, it is. It's still running. Okay, cool. So this is NodeUp running behind the scenes. And remember, NodeUp is a tool that sort of solves the same problems with kubeadmin, but it does it in a different way, and then we have some concerns with it as well, specifically around how far away it falls behind Kubernetes upstream. But it does do a really darn good job at bringing up an HA cluster for us. So again, I think there's like some pros and cons to this, and I think, you know, Kops was sort of the pioneer here, and I don't want to pick on Kops too much because it's really how I got into Kubernetes. But yeah, it's just interesting to see how the space has grown over time. So yeah, it says Cloud Init finished. Let's see if we can open up a new tab. Let me zoom in and resize. And let's kget nodes. Do we have nodes yet? Do we have nodes yet? While we're waiting for that, let's look at how Kops is distributing load across the masters. This is good just to know. Like, a lot of folks like struggle with, okay, I was able to create a cluster, but what is my cluster? Like, what components, what resources make up my cluster? I know because I drew a bunch of graphs on this like 2 years ago, but also I just know because most Kubernetes clusters kind of do the same stuff. But here in Kops, we have a load balancer that we've created that's going to help us distribute our load across our masters. And it says unable to connect to our master server here. We're going to wait for this to come up. Okay, so while we're waiting for this to come up, it's been almost an hour and 40 minutes. I got to get out of here. It's Friday. I got an interview here in a few minutes I got to take. So it's been great talking about Kops. It's been great looking at some of the old source code. Thanks for joining us, everyone. Feel free to start dropping in your goodbyes now. We're going to wait to see if we can't get this cluster to come up while I'm kind of giving an overview of everything we talked about, and we'll do one more sort of pro and con of Kops and Kubicorn and the cluster API high level here at the end while we're saying our goodbyes, and I'll get off the air here in the next couple of minutes. And while I'm doing all that, I'm going to be simultaneously trying to get nodes from our highly available cluster we just created. So yeah, again, Kops was one of the big pioneering projects. It borrowed a lot from Terraform. I borrowed a lot from Terraform, borrowed a lot from Kops when I created Kubicorn, and you know, after writing the book and really exploring the space, you know, it sort of seemed to me that having a really clear abstraction between the infrastructure bits and how we manage and mutate those, and then the actual Kubernetes bits and how we manage and mutate those, are very important to keep those concerns separated. And we see that in the cluster API, where we have a very distinct cluster definition and then a very distinct machines definition as well. And the cluster definition is all the Kubernetes layer stuff, and the machines is all of this like underlying infrastructure goop underneath. And you know, we saw that Kops and Kubicorn both provision infrastructure as well as Kubernetes on top. We see the implicity with how a user would interface with Kops. We learned about the different types of data stores and how Kops uses S3, but how Kubicorn uses Git or your local file system, or if you wanted to implement any store on your own. And then we compared that to the cluster API and how the cluster APIs are using Kubernetes proper primitives and actually storing them as aggregated API server objects or as a CRD. And so there's a lot of pros and cons here, and I think what's important to know is that like there's no right way to do this. There's good things and bad things about every way, and I think that, you know, as Kubernetes matures and as the infrastructure space matures, like we're going to start getting this stuff more and more fleshed out, and we're going to start learning about the boundaries. And that's really like the big lesson I've learned in the infrastructure space is it's less about the ability to do something and more about where you draw the boundaries in the software so that you can interface with different components of the infrastructure stuff downstream, and you're not crossing over and munging stuff together. And I feel like both Kops and Kubicorn kind of are both a little bit guilty of munging too much into one command or into one project. And as I started to try to maintain Kubicorn over the past year, I totally got my like hands full, and it got to the point where there was a lot going on here. So definitely a big fan of keeping the controller pattern in there, keeping the operator pattern in there. Definitely a big fan of the work that's been in Kops for everything from the CIDR stuff we talked about earlier to just getting it right and being the first of its kind. And even like inventing a tool like NodeUp when there was nothing else there, just to keep users using Kubernetes. We owe a lot to it, and I think it's important to bring this stuff up. So yeah, that's the high level history of where all the different pieces fit in, how I got involved with it, where we are today, where we're going in the future, if I have anything to do with it anyway. So let's try Kegit nodes one more time. Poof, highly available Kubernetes cluster in Amazon. So yeah, that's all I have for today. It's 2:41. Let's look in chat and say goodbyes, and then I'm gonna get out of here and enjoy the rest of my weekend. Still don't know what I'm doing this weekend. I might go for a hike, which might actually be like a low-key mountain climb, or I might go to a fish concert. I'm still trying to figure out what I'm doing. But let's say goodbyes. Okay, so folks are saying there's a link URL. Looks like somebody pasted in there. Sean says, have a good weekend. Marco says, great job, Kris. Olaf says, good job as always. Nicholas says, great job, Kris. Gif says, thanks. Pablo says, thanks. Joe says, for people who want up their terminal game with sound effects, there's a way you can do that. Abdebnor says, Kris, awesome review of Kops. That's why in our enterprise, we're not able to move easily to AWS EKS after seeing Kops benefits. And Texan says, have a great weekend, Kris. So yeah, thanks everybody. And again, there's no right way to do this. There's no wrong way to do this. There's just different ways to do this. And yeah, this was my quick and dirty overview of Kops live on a TGIK. Oh, Olaf says, take a hike is not a rude thing to say. Actually, it is to me because I do not identify as a hiker. I identify as a climber, but my hand's broken, so I'll be getting away with it by calling it a hike, but really I'm going to think of it as a climb. But yeah, I'm very weird about the word hiking. Anyway, more on that later in a different TGIK. It's Friday. I'm going to get out of here. So thanks again for hanging out, everyone. We love seeing you here. We love to in TGIK. I think Joe might be on next week, but I'll have to talk to him about it. But either way, we will see everybody. Sorry. And no, Olaf, it's totally cool. You didn't do anything wrong. Okay, I'm going to get off now for real. Okay, bye, everyone.